to start with a land acknowledgement. We respectfully acknowledge the province of Newfoundland and Labrador, of which the city of St. John's is the capital city, as the ancestral homelands of Beothuk. Today, these lands are home to a diverse population of Indigenous and other peoples. We would also like to acknowledge with respect to the diverse histories and cultures of the Mi'kmaq, Innu, Inuit, and Southern Inuit of this province. And I'm just going to share for a second and just show you the agenda for tonight. That's partly just to make sure that it's also working. So can people see that screen?
Yeah.
Okay, so I'll be introducing Phil in a minute. He's going to give us an update on the meteorite that landed in Golden, BC. We'll have some observation reports. Nikolai will run through the sky this month, and then we'll just have sort of a festive sort of social interaction, unfortunately without all the cookies and treats that we would have had if we were living in different times, and maybe someday we will, but we'll see how that goes. So we have a few visitors. I just want to welcome all the visitors, and again, if we were sitting in a room at MUN, we would all go around and introduce ourselves, but everybody kind of disappears when I'm sharing the screen. So I'll just remind you that the meetings are open to the public. You don't have to be a member, and anytime you want to attend one of the meetings, you can just, they're the third Wednesday of every month except for July and August. You can send an email to info@stjohnsrsc.ca and Randy will send you the meeting announcement. But if you want to become a member of the Royal Astronomical Society of Canada, oh, by the way, my name's Mike Mullen. I'm the president of the St. John's Center. And
You're here.
Then some of the benefits include sort of interactions with the people in the group who can help you learn something about astronomy. You don't need to be an expert in astronomy to join. I certainly wasn't, and still am. I'm sort of halfway there. I may be intermediate now. There's a chat group, rescnltalk.io, where people share pictures and discussion and sort of alerts if something interesting is happening in the sky, or they use it to organize getting together to do observations. There are some publications which you can see down here. Hopefully you can see my little hand moving around. Sky News, which is a great sort of general astronomy magazine. The Journal, which is a little bit more scientifically based, but also an excellent publication, The Observer's Handbook. We have equipment rentals, some telescopes, a solar telescope, accessories, very cheap, maybe $10 a month. A good way to, if you're thinking about getting a telescope, a good way to try things out. And when times become more normal, we might be able to meet up and go for observing sessions out in Butterpot. And there's a way to join. Basically, you go to resc.ca and navigate through everything, and you join the RESC, but you indicate an affiliation with a local group, and that would be us, if we would hope. Doesn't have to be, but that'd be nice. So with no further ado, let me introduce Phil. In October, there was a story in the news, a little bit of coverage about a meteorite that went through somebody's house, somebody who was very lucky because it missed her, it hit the bed in Golden, BC, and Phil has been involved in investigating that a little bit. So he's going to give us a bit of an update on that. Phil is a member here, and but he's based in London, Ontario, and a little bit in Toronto now. He got his BSc and MSc from Memorial, his PhD from Western. He's the director of the Western Paleomagnetic and Petrophysical Laboratory. He's an adjunct research professor at Western. He's interested in paleomagnetism and in the geodynamics and petrophysical properties and mineralogy of Earth and planetary materials. And he's an expert in meteorites, and he's doing something at the Royal Ontario Museum, which I don't know much about, but maybe you can tell us a little bit about that at the beginning. So, Phil, I'm going to stop sharing, and would you start sharing and
Sure.
Take it away?
Sure, okay. I'm just going to pick up on that one. Fine, okay. We'll do that. Just to explain myself a bit, thank you very much, Mike. You covered pretty much all the bases there as far as I know. I have as anybody who knows me, I have a pretty busy life, it seems, at most times, and this is no different now. Modified, of course, by the pandemic, as it is for everybody. But these days, I'm doing a lot of work at the ROM, actually, and I'm helping them with their meteorite collection right now as well, doing some typing of meteorites, just basically characterizing meteorites, getting them submitted. They have a backlog and they need some help with that, so I'm helping out with that too. Can people see my screen, I hope? Grinding away. Here we go. Yes.
Yeah, see it now.
Great. Okay. I was trying to get my Zoom to, oh, I see what's going on. Okay. To disappear enough so that I can see what I'm doing. That's sort of the classic Zoom presenter problem, is you're so bamboozled by what Zoom is doing that you can't actually present. So anyway, here we are. Yes. So that's what I'm doing right now at the ROM. The phone call. I can't do anything about that. I'm currently in Hamilton, Ontario, oddly enough. This is where I'm staying. So I'm now based in Hamilton, at least for part of the week, and I happen to be there on Wednesdays, Thursdays, and Fridays. So a monthly meeting caught me basically in transit from Toronto back to here. So I was a little bit discombobulated coming back here, but happy to be here. And I'm going to give sort of an update on what's happening with the Golden BC meteorite. This is the first group actually that I've given a presentation to about this event. So you're going to get kind of a trial run, I suppose, but we'll see. There's actually a lot of interesting things to talk about. I've pared it down to some essential details and a little bit about how we're getting the information along the way. But the upshot of this is that the object you see on your screen is that hammerstone. It's a 1.2 kilo meteorite that came through Hamilton's roof. The image on the left is a very nice image taken by an astrophotographer who will be mentioned in a moment at Lake Louise. A totally fortuitous thing. You can see stars. I don't know if your image is as good as what I've got on my screen here, but if you look closely in behind the clouds here, behind the fireball, you'll see stars. You know, this is a perfectly beautiful registered photo. If one wants to get a trajectory, this is exactly what you want. So just by happenstance, this person was getting a photo at Lake Louise looking west, and blammo, the fireball happens at 10:30 at night on October the 3rd on a Sunday night. So yeah, amazing. Anyway, so it's one of those things, meteorite events, each one is unique. There's always, you know, little happenstances with things, and this one is no less fantastical for what had happened as compared, say, with Tagish Lake and with Grimsby, both of which I've been involved with, that I've you know, talked with you guys about before, at least some of you here. So anyway, just to recall something here, let's make sure I can actually advance. Yes, good. Here is the 2009 Grimsby Fireball event as seen from an all-sky camera here in Hamilton, actually at McMaster. The camera's installed there. Just a reminder of kind of some of the things we've done in the past. where we have images that give us an idea of more information about a fireball event. Aside from people observing it, you actually have images that are registered. Basically, you can figure out what the trajectory is, and you can, for the occasional meteorite fall, you can actually figure out what the orbit was. So that's kind of a gold standard that we try to meet with any meteorite fall event, is if can we gather enough information to actually give it that contextual information for the orbit of where it came from in the solar system. There are currently about 50 of those known in the world. At the time of Grimsby, it was more like a dozen. So there's been actually more like 20. So it's really come on in the last decade. Grimsby, some of you will have seen this before. This was an Ontario event. The names on the map here are fireball camera locations from Western's network. Basically, just checking the chat. Okay, post questions in chat. Okay. This is the fireball was seen coming out of Northwest, and it ended up around the Grimsby area, seen from all these cameras. So it was possible then to basically make some prediction, more or less, of where fragments came down, and we put out a public notice, and these folks responded, the Garchinskis, and they had a piece that hit their SUV parked in a driveway and smashed the windshield. So in meteorite collecting circles, this stone is called a hammerstone because it interacted with something that has, I just admitted Robert Babb, okay, something that has interacted with something human, you know, so it's either hit a fence or hit a car in this case, or, you know, occasionally hits a structure or a house or some other thing. But it has a special kind of, I guess, mystique and a higher collector value because it has a big story attached to it. So hammerstones are interesting. There's the hammerstone for Grimsby. I guess the title is cut off here, at least for me. But basically, it's a hammerstone broken into pieces when it hit the driveway. So what about this golden event? Here's the lovely image by Hal Quinn from Lake Louise in Alberta, looking west, and the fireball itself had starting from the upper right, heading towards the lower left, and it basically had a few burst points towards the end, and then ended up in a few embers at the end. So it's a pretty neat event. This is a little bit modified as an image goes to try to stretch it around in order to bring out all of the details in here, but it's just gobsmackingly beautiful image, and very important for working out the trajectory, as it turns out. So this is one of those beautiful examples of beauty and science together, all in one image. Just fantastic. This is a animated GIF image. So you see crawling around in the corner of this image I believe this is Don Vladiak's camera. I'm not actually 100% sure if this is his all-sky. There are a few all-skies involved in this up in Alberta, but his was an important one. All of them were at some distance from the fireball event in BC. So this is basically dropping through the sky and showing the final bursts coming as flashes towards the end. And this is from a trajectory solution purposes. It's good to have the information, but as you can see, you know, that's down near the horizon here. The all-sky camera overhead is straight overhead. The horizon is all of this ranging around with trees and whatnot on the horizon. You know, that's all. If you think of the geometry of this very simply, stuff that's low on the horizon, and this is happening typically, you know, 80 kilometers up, and it ends at just below 20 kilometers altitude. Well, if you do the, you know, Pythagorean triangle, even ignoring the Earth being round, that's a long way away. That's, you know, a couple of 300 kilometers away, you know, so it's pretty low and more difficult to make calculations of that trajectory. But you get enough of them, you get a sense of the trajectory, and especially with camera records like this, you get timing very nicely. So that's very helpful. These next few images are the other source of major information nowadays is security camera images, and there's an installed infrastructure of security cameras basically everywhere there's anybody living. So this is a second by second by second frames secured from a security camera at Sunshine Ski Resort at Banff. So this is basically, I guess, near the top of the hill. You'll see there's a couple of ski lifts here in the foreground and the beginning of the fireball. I hope everybody can see my pointer there. Just near the top of the screen, you can see the starting trail of the fireball. And as we advance through here, next second, it's starting to really brighten up, heading down towards Golden, as it turns out. There it is, bright bursts, getting close to daylight. You can still see some stars, but getting close to daylight there. And now it's maxing out the range of the camera. So and then now we're getting towards the end. And there we are with the last little embers of the event there. And then finally, you're back to darkness again. So just very quickly, I'll run through that again, just because it's fun to look at. So I'm doing that almost in real time. That's what it would have kind of been like if one was standing at the ski lifts there in Banff. So a nice map of this that Peter Brown and folks have put together. There's a lot of different team members involved in doing this work. I'm basically at the rock end of the work, so I'm currently talking about basically other people's work. Peter Brown and Alan Hildebrand and other people and Chris Hurd at University of Alberta, Alan Hildebrand at Calgary. There's the BC-Alberta border basically cutting between the two provinces here across this map, and then the 49th parallel is the Canada-US border there. So Golden is basically just to the southeast of that cross on where the red line is there. That's the ground path, the projection of the trajectory, and the end height is basically where the cross is. And all these other symbols are useful constraints on the trajectory, different observatories and places. So that's Sunshine Ski Resort is right on the border there, Alberta, BC. So that's pretty good. Lake Louise isn't plotted on here, but it's basically over around right there. So another excellent view. And then other all sky cameras and other video cam kind of things elsewhere help constrain the trajectory very well. So we get the endpoint around 18 kilometers altitude, which is pretty low. The velocity is 16 kilometers per second, relatively slow, but certainly in the range. And usually when they're that slow and get that deep, they will drop something, as this one did. So the other thing is local observers reported a couple of booms. So here's the other end of it. Where I come into this is I'm sitting at home on, this happened on the Sunday night local time on October 3rd. So by Wednesday, I'm sitting in the evening and I open up my email and looking at some email that's come in, automated email from the Impact Earth site that Western operates and basically collects meteor observations from Canada and elsewhere. And a note came in from someone named Ruth Hamilton, who said that a meteorite came through my roof and landed on my bed. That's pretty breathtaking as an opening line. So the next message had images attached. So I was just sort of internalizing the first message, and I opened the next one, and these images popped up, and I went, "Yep, it sure did." This was clearly correctly a meteorite. There's no question about it. You can see at the upper left here, there is indeed a hole in the roof with everything angled correctly, coming through and depositing something with debris on the bed. And there it is, a close-up view of the meteorite sitting at the pillow. And wow, and it's clearly a fairly blocky looking but appropriate looking object for being probably an ordinary chondrite meteorite. So right away, obviously this was the real McCoy. So I got in contact with her, and we agreed to talk the next day by phone. My first discussion with her really was to, establish more circumstances of the event, which I'll talk about in a moment. But also a very important thing that we do whenever we're responding to anything like this, somebody walks in with a meteorite, or especially an event like this, the Garchinskis in 2009, this happened, especially an event where, it's a hammerstone, it's of interest in the meteorite collecting community, and it's a great story. So it's interesting in public as well. What happens is it's going to kind of change their lives, at least for a while. And I want to make sure that Ruth was aware of the sometimes intense interest that comes from the meteorite collecting community for things like this. So part of my discussion with her was to gather information, but also partly to be available and provide advice as needed, as she was negotiating through, getting people in, like her insurance company guy was going to come by and look at the damage to the ceiling and what to do about that. And as it turned out, he tried to buy it off of her. She said no. So she's actually very sharp, and she's on the ball. So turns out she's no worries about her being able to handle all of this, but that's not always true. People sometimes really don't know how to handle all of the public attention. So part of our job, I think, is to try to help people do that. Anyway, so a bit about the event itself. You probably, if you've paid any attention to the story at all, you probably know the major details, but essentially, this was the evening, about 10:30 in the evening on the Sunday night. Ruth was in this bed, and her dog was with her in the room, and her dog suddenly started barking as if there was a bear in the backyard. A bear in the backyard kind of bark. Now, they're in Golden, BC, so they're in a town, in the middle of a town. But there are bears around from time to time. And so the dog was raising a ruckus, and that woke her up. And then a second or two or so later, all hell broke loose. And basically the room, there was a big bang in the room filled with all of this debris and dust and everything, big commotion. So she got out of bed, turned the light on, was trying to absorb what was going on. Why was there all this mess? And she noticed the hole in the ceiling. And then eventually she moved her pillow and saw that there was this rock that had come through the ceiling. And so she did what any sensible person would do. She called 911 and said that something has happened. There's something come through the roof. And so the Mounties responded on call. And so they were trying to figure this out. And it turned out that the police officer had also stopped and was outside his cruiser elsewhere in town, trying to figure out what all the flashing was. And he had heard two booms from inside his cruiser of the meteorite fireball event sound reaching the ground. He'd seen the flashes, heard the booms, and he said that it was not the usual rail yard kind of booms that happen with cars colliding and so on. There's another view of it while I'm talking that she took of it on the pillow. Now, she was on the pillow over here next to where it landed. So you can see some of the marks on the pillow where it hit the pillow there and scraped through. And you can see on the meteorite itself, we'll see a couple of views later on, where it actually carried through a whole bunch of roofing material. And all these black objects here aren't pieces of meteorite, they're asphalt from a roof. So it came right through, brought a bunch of material through, spewed it all over the bed, and it landed basically one head's width away from her head on the bed. So very, very close call. So they together, Ruth and the responding officer, suspected that, well, okay, well, maybe this might be, there's highway construction going on in the Kicking Horse Pass, you know, a few kilometers away up the hill. Maybe it's from that, maybe they're blasting or something. So the Mountie got in touch with the folks at that site, and they said, well, no, we didn't do anything, but we saw a big flash in the sky and heard two booms. So it was obviously a big widespread event, and they knew at that time, oh, this must be from the sky, it must be a meteorite. So they knew right away pretty much that this was a major event and a big thing for Ruth in her life. And she thereafter took about 2.5 days or so to sort of absorb this, and didn't talk with anybody except for friends and family. And then finally on Wednesday, she started figuring out, well, okay, who do I talk with? She talked a bit with the local paper, which of course would make it public in a few days. She also started figuring out, who do I reach out to for websites and trying to report this. So she reported it to the American Meteor Society site. So there is an entry for this event on that site where she says, you know, this hit my came through my roof and hit my bed. And nobody particularly noticed at first on that site the significance of that entry. And then she hit our impact earth site, and that's where we started. There is a view of the roof later on. She stuffed some newspapers into the hole up there to try to keep the heat in and all of that, but that's basically what the damage looks like right at the roof line. And outside on top of the roof, this is what looks like a tin roof with asphalt underneath, and then there's plywood, and then you're through into the gyprock on the inside. That's basically the layers in the roof, and this is what it looks like when a 1.2 kilo object drops at terminal velocity and comes through a roof. This is what it looks like. So she's now got a patch put on this, and some of the original material has been taken away. Some of our advice, and people have been in contact with her, obviously trying to retain the aspect of this so it's not disturbed very much, because people will want to collect it. The people will want to buy things like this, cut out a portion of the roof, save it. I'm not kidding, people do this. And indeed, she has had offers. She's also, in case I forget to mention it later, she's also had an offer for her entire bedroom set. I kid you not, people want to actually buy the entire bedroom set because they would like to recreate what the conditions were like at the time when the meteorite arrived. And, she'll obviously get something new with all the money she gets for the bedroom sets. Yeah, anyway, I gave her some warning that this kind of attention and offers were going to come with this event there. So this is the hammerstone in Ruth's hands, which she took after a while. And it shows a couple of things. It shows some very basic things about meteorites. All meteorite falls of ordinary chondrites typically have this kind of blocky looking appearance, brick-like almost rounded surfaces. You can see these dents in the rock. They're called regoliths in meteorites. Basically, they're ablation surfaces. So when it was coming in, it's a stony object, but it's coming in through the atmosphere. Portions of it get carved away by the hot plasma that's sort of surrounding the object as it's coming in. With the energy of the event, it basically makes the atmosphere around it become a plasma, and that eats away, ablates away portions of the meteorite, making these kind of characteristic scallop or thumbprint kind of shapes. And so this is a very classic look to a meteorite. Then what remains on the surface here is the immediate surface of the rock with all the heat gets melted into a fusion crust. Basically, it's just the material of the rock and a bit of atmosphere combining to make material that coats the entire, in this case, the entire 1.2 kilogram fragment is entirely coated in this millimeter thick fusion crust. But the stone inside the rock is basically unaffected by its passage to the atmosphere. So that's the basics of the meteorite. Yeah, this is a good looking but basically typical kind of ordinary chondrite meteorite fall, a nice one. But it also has these very characteristic looking scratch marks on scrapes, and in places there's asphalt adhered to it, and that's from the roof. So this stone in particular, as a hammer stone, it has very much more interest in social or cultural interest in that sense, and collector interest, because it's a stone that interacted with the structure and bears all the marks of having come through her roof and landing on her bed. So it's just a remarkable object. So here is sort of just a Google view of downtown Golden. And I don't have a zoomed out view, but if you zoom out, there's a Columbia River's over here. There's the Kicking Horse River coming in from the east and dumping into the Columbia River just off screen here. If we were to zoom out and look at this, it's basically, as you know, eastern BC is mountainous, quite mountainous. You saw in the photo from Lake Louise. And this is an incredible bullseye for an object to come just, more or less randomly, and it comes in through the Earth's atmosphere and delivers meteorites on the ground. Where? In the middle of a town, in the middle of eastern BC. What are the chances? It's just amazing. So there it is. That's Ruth's house down there where the yellow dot is. And a second one was found not long afterwards by folks from the University of Calgary. They were out searching the Stroomfield area and turned up a second fragment, which I'll show in a moment. This is the work done by Alan Hildebrand and Lincoln Halton, I think his name. I'll get his name in a moment. It comes up on the screen. He's a grad student with Alan, and they together have worked out from their initial solution what the fragment fall area or strewn field is likely to be for the golden event. This is before they knew about the main mass that had landed, or indeed before they found that one, the second one. They basically had this map with these rectangles, blue rectangles already on it. And the blue rectangles are estimated fall fragment sizes. So 1 to 5 kilos is this dark blue area. That's where you'd expect the biggest pieces to land. And it grades off 1 kilo kind of area, 500 grams max area, 100 grams up here. As you go up the slope and into the bush, you basically get smaller and smaller fragments. So the fireball came in from the northwest and exploded somewhere to the northwest of town, and fragments continued a long trajectory, getting deflected by the wind a bit. So that's what gives it this kind of weird fan-shaped pattern, is the small fragments get blown off to the northeast by a wind out of the southwest. But the big guys don't get deflected much, and they basically land on the bullseye. And that's their prediction. And the big 1.2 kilo fragment was found basically right fat in the middle of their predicted area. Just remarkable. Good work. And you know, the sub-kilo fragment is where it should be in this range. You know, that's a 700 gram fragment that was found here. So yeah, nothing else has been found. So there is the 700-ish gram fragment found by Alan and Lincoln. And this one's got most of the fusion crust on, but also very helpfully has a broken surface, so you can see the inside of the meteorite. Here it is. And you can see all these little round black things in this view are chondrules. So this is a chondritic stone, basically a primitive style of meteorite. The most common kind of meteorite that hit the Earth are these, and they're basically material that never formed planets. They're kind of primordial material that ended up being the feedstock that made planets, and some of it's left over in the asteroid belt and eventually makes its way to the Earth sometimes. And there's also some metal in here, not really visible in this view. But basically, this is a kind of a typical appearance for probably an L chondrite, low in iron, ordinary chondrite. So we got the meteorite on loan from Ruth. This is the hammerstone again. And you can see, again, that characteristic scrape mark of it coming through her roof on this surface. This is maybe a nicer, more detailed view with some of these dimples in the surface. And there's the mass right there, 1.268 kilos. And we flip it over, and this is remarkable. That stuff that's glued onto it by the force of the impact coming through the roof, that's asphalt from the roof. And all of these silvery marks on the surface, that's tin from where it scraped its way, tore through the tin roof, adhered asphalt. And there's also little bits, you can't see them here, but little bits and pieces of wood chip from the plywood. So it's a mess. It's quite a mess, and it made it a little more tricky to handle because that's all friable material. And because this is a hammerstone and it's valuable, we actually don't really want to have stuff falling off of it. So the main problem that I had working with this while we had it on loan was to make sure that we didn't disturb it and retained all of this and get it back to her in one piece, as it were, because it you know, ultimately has that kind of value. One more view of this, now looking at that bottom. So this is this square part on the bottom down here. When you look at the bottom, it's kind of more brown looking, not just the lighting difference. It actually is kind of more brown looking. And you can look here and there, you can actually see some of these little round dots in there. They're chondrules. So the fusion crust on that surface is thinner than the fusion crust elsewhere. And this happens sometimes with individual stones, is the fusion crust gets really well developed on some surfaces, and then other surfaces not so much. Yeah, they basically has a very thin coating, so you can actually see through that surface and kind of get an idea that it's probably an L chondrite just from that view. So some of the work, I'm going to just proceed quickly through some of the things we have done so far with golden and get a chance to chat about it. Here it is sitting on a turntable. This is a student currently working with me for her honors thesis on shatter cones, actually on a different project. So we were imaging shatter cones. So this arrived at a time when she was doing much imaging. So she's doing imaging here of the golden hammerstone. This thing. Her name is Olivia Benest, I should say. I keep forgetting to say that here. So Olivia here is holding something that looks like an iron. It's basically a camera that's able to get and record a succession of images. And as you turn a turntable, it builds up a three-dimensional view of whatever's on the turntable, and also records color information. So you get a color map in the end, an albedo map for the object. So you can do that. You build a model of it. There's a bunch of things that we're doing here with the model. So that at first it looks kind of fuzzy because it's got all these extraneous stuff that you have to clean up out of the view and retain just the model. So there's the turntable in red down there. So you cut that out. You can eventually end up, you get all faces that were sitting on the table. The thing that was kissing the bottom of the table, of course, wasn't recorded. It's blank. So you have to flip the meteorite over and do other views. You have different views. It merges everything. You get a 3D view of the stone. There's that adhered asphalt on this modified surface of the stone. There it is. If you render it just with a nice surface detail kind of model without trying to put colors on there, you get a really good idea of what it looks like in really good detail, sub-millimeter detail, of what the surface looks like for the meteorite, including all of that adhered asphalt on that surface. So from that, we can get a volume for the meteorite. We can estimate then its density, knowing its mass. It's 3.2 grams per cubic centimeter, which makes it, that's pretty low for an ordinary chondrite, but about right for an L. So that helps us with the definition of the meteorite. There's a kind of a more cleaned up view of the surface, and there's the asphalt again on this surface. So it's pretty neat. The other thing we can do is, aside from that visible light scanning, which is just the surface of the meteorite, we can also put it on an industrial style X-ray CT scan setup, so computed tomography scanner. So there's an X-ray source here pumping X-rays through it to just off screen here, there's a big detector screen. And we basically pump X-rays through. It's like a medical scanner, except they're more intense X-rays because it's intended for industrial kind of applications, or in this case, this is at the Museum of Archaeology, so it's sustainable archaeology, so it's at Western, so it's usually intended for artifacts like pottery and skulls and things like that. But here we can put meteorites on here and do the same thing, and you can require X-ray images frame by frame by frame, and it too is, you know, like the other ones on a turntable, and we basically are able to assemble a whole bunch of images like this. You can see just this one radiograph, you can already see kind of through there that there are little dense bits in here that are absorbing X-rays more, like the bones in your hand would. That's little metal grains sitting inside the rock as the X-rays pass through. So you do the computed tomography is basically a big mathematical solution of all these different ray paths for all the known image geometries. You can reconstruct in 3 dimensions where those denser parts of the meteorite are, and you can reconstruct the shape of the meteorite. So this is an example of one of the beginning of the reconstruction of the meteorite, where you can see the dense areas are represented by bright spots in here. So these are all little metal grains in this particular slice of the meteorite. You notice it kind of dims down in the center here, it's darker. That's because it's actually tough to get X-rays all the way through the stone and out the other side without some dropout of information. So this stone is just large enough that we're just starting to get underrepresented with information in the center. So it's called beam hardening. So it's a little difficult to reconstruct the center, but we still can happily. So the next few images basically are just reconstructed 3D models of what it looks like. The coloring's not quite right for the surface here. We hadn't yet put a map on this with the actual look of the meteorite. So this is basically just rendering what the surface more or less looks like. But it is correctly picking up very nicely, finely, where the cracks are on the surface. It's pretty neat. There it is again, one of these little tinier dimple in there, and basically picking up where some of the surface is. These little bright specks, the bright and dark on this surface is not correct in real life, but it is picking up where little protuberances are from the surface. So it actually highlights some of the roughness of the surface that we don't see in the pictures of it. If we sort of make a lot of the stone go away and just look at metal in a meteorite, it can reproduce that in 3 dimensions. So we get an idea of the 3-dimensional distribution of what the metal is in there. And you notice there's bigger and smaller globs that are millimeter size or larger. But also here and there, we'll see in a few images that there are little veinlets as well. There's one here. This is a slice of, if we're passing through the stone, successively rolling through at about 50 micron scale, so 0.05 millimeters at a step. Basically, we're picking up these sort of little bit bigger than millimeter size metal veins in here, which suggests that the stone's probably a little bit shocked because it's moved the metal around. So I would expect, we haven't yet had a good thin section cut of the meteorite, but I would expect to see some evidence of shock in it from that. So again, here's another slice section of it. And intriguingly, here and there are patches that are devoid of metal. So that's kind of interesting. We can see that. I'm not sure that, no, we didn't get it in the last few here. There's a few places where it looks like there are clasts in this meteorite too. So something else we'll look for is to see if it might contain other bits of possibly other evolved versions of this type of meteorite. So last part of this I'm going to talk about before I quit gabbing is this is a reconstruction of the 3D model of the meteorite just in grayscales, looking at the outer surface. Again, you can see some of the cracking in here that it's picked up on. And cracking is just, that's what fusion crust does. As it cools down, it just does that. You know, like a lava flow as it's cooling down, make cracking on the surface. This green area, we're trying to estimate where to do a cut. We need to classify the meteorite, and we need sample in order to do that. So a negotiation ensued with Ruth Hamilton about being able to do that with the type specimen fragment. And we were able to do that with her, which is great. So it was a task put to me to figure out where to do the cut on the hammerstone, which is no easy task because obviously we don't want to disturb the parts of it that record it coming through the roof. So in the end, it came down to only one corner was suitable for being able to make a cut. So I've basically modeled where, in discussion with Ruth, modeled where that cut could be here, figured out what, you know, how much mass would be involved in doing that. So the CT data is very useful for being able to manipulate the object and, you know, make these kind of estimates and what would the footprint basically of the cut look like, so that as collectors say, you'd have a window to look into the stone that's otherwise entirely fusion crust, you'd be able to see into it. So we did that. This is a wire saw that we have at Western in my lab that I operate. And so we basically had to take the meteorite because it's such a weird angle, because it's a corner. My usual way of holding things didn't work. So we had to sort of jerry rig a clamp system here in order to hold it. And we end up with it basically looking like this, basically like it's wrapped up like a baked potato and held carefully in a clamp with padding and so on. But this is the exposed corner of that stone. There's the wire intended to make the cut, and the wire basically runs on the pulley back and forth. So it's an open-ended wire, just runs back and forth with airflow in order to do the lubrication cooling of it. You can see that here, the air is coming in from either side and blowing dust from the cut away. That's it. It started to cut up here. It's on its way about halfway through the stone, passing through the stone, in order to take out that corner piece. And there is the corner piece sitting on the collection foil at the bottom. This is from straight overhead looking down. The wire has gone right down the face of that cut there and dropped the piece off the other end. So very nice. Heart in my throat all the way, but yes, nicely done. And there it is. There is the cut of the hammerstone still wrapped in the foil there. So that's what the window looks like. And you can see similar to the Calgary piece, but now there's a nice fresh cut surface showing all of the chondrules sitting there and some of the metal. And this is the piece that was taken off at 42.8 grams. And there it is there, probably a nicer camera view with a scale in centimeters at the bottom here, showing that cut piece. So the stone after the cut, it's still 1.2 kilos, down some, but down to 40 some grams, plus a little bit lost to the cutting. So that's kind of typical for making a specimen from the meteorite. But now the hammerstone has all the features of a hammerstone and a window into the interior as well, which is neat. So I think this might be one of the last slides. I have one more thing to say after this, but this is it, a little bit out of focus maybe, but that's me holding it after the cut and just before we packaged it up to bring back to Ruth. So a couple of final things about this, you know, significance of this scientifically obviously there's a lot to talk about with this being a Hammerstone event, and it is a fun story and an exciting story. But what's interesting about this event is it's also scientifically really interesting, because it turns out the orbit, the solution for this has the orbit. We're taking what is for us as amateur astronomers a very familiar view, looking down on the solar system from above, from depictions. If you think about where the planets are orbiting the sun, well, here's the Earth, and from the Earth right now, you're looking out at night, you see Jupiter, and just off from a view from the Earth, Jupiter's here, Saturn's just off to the right of Jupiter in the sky, and right here, there's Venus in orbit closer to the sun than the Earth, and in our sky, in the evening sky here, well, Venus is off to the right of Saturn. So basically, this is kind of a familiar view for us. Geometrically, this is the orbit of the object before it arrived on Earth. So golden in orbit around the sun, it was just out the aphelion. I have this wrong here. It should be aphelion, not perihelion. Sorry about that. The aphelion, farthest point from the sun, is just out tickling the inner part of the asteroid belt here, the main belt asteroids between Mars and Jupiter. Between those two orbits there are most of the asteroids. So it basically has its farthest point from the sun sitting out there. And so that basically means that the orbit for this L chondrite is what's called a rather evolved orbit. It didn't sort of get liberated fairly recently from the asteroid belt and just swing in on an Earth crossing orbit. In order to have this kind of orbit, it has to have had some kind of further interactions, either with Jupiter to perturb it further in, or other interactions that would modify its orbit as a kind of meter-sized object. So that makes it immediately interesting because the handful of other L chondrite meteorites all have aphelia sitting further out in the asteroid belt. So they kind of have a simpler delivery history. This one's more complex. So we would like to get a cosmic ray exposure age for this rock, and to estimate its size before it hit the Earth's atmosphere. So probably something meter size is what arrived, but we would like to get a much better handle on that by working on small pieces from that cut type specimen that you saw. And I'm currently, my job is to officially describe the meteorite and get that done with the meteoritical bulletin so that it becomes an official meteorite known as golden. And we can then proceed with and publish all of this other work that we're setting out to do. Anyway, I think that's it for me. Sorry if I took a bit more time, but or not, I'm not sure. But I just thank Ruth Hamilton, the finder, for putting us in touch with all of this to begin with, and that's an amazing event to have happen in anyone's life. But no, she's responded to it really remarkably as well. She's very serious about getting the science done, and also about it being a really fun event to share with people. So no, she's really fun. And there's a whole bunch of us working at Western in Calgary and University of Alberta with Chris Hurd with some of the all sky camera images. And then the 3D imaging involved people here at Western, Andrew Nelson and Olivia, my student, Olivia Benest, and the technician Eric Eastaw. And then there's a bunch of other things. I won't run through them, but there's websites. A really nice website, by the way, if you want to dig up a lot of information, is this German website on meteorites. You can look up basically anything about any meteorite on that site. It's remarkably well done. And the Golden event has all sorts of information, basically a lot of what I talked about here, aside from some of the internal things we're still working on. But all the public stuff is all well documented there. Anyway, and that's it. I don't know if we have time to talk about stuff or want to move on and we can talk later. That's up to you guys. But no, that'd be really fun to talk about this.
Oh, thank you very much, Phil. That was great. I'm sure we got time for a few questions. I think what we've got in the chat so far are just comments.
Okay.
But that was really interesting. Anyone have a question? You can unmute yourself and ask it. I guess I can start with one. So Do you know what's going to happen to the meteorite now that it's gone back to
To Ruth?
this person, back to Golden? Which, do you know what she's going to do with it?
What she says, she's not in a hurry to do anything with it. She's obviously, you'd expect, she's had offers. People want to buy it, and meteorite collectors and so on, and some high-level collectors, the usual suspects for this kind of thing, have all, basically come forward wanting to buy it. And she's not in no hurry to do that. She wants to sort of over the winter, have a chance to visit with her various family members and, basically share the event with people. It's a personal thing that happened to her. So she wants to kind of share that, and then she's going to sort of reassess. And she would like to ultimately see it go to perhaps an institution, like a museum or something, where it could be, a publicly shared object, or it could go to a private collector, perhaps. She doesn't have super strong feelings, as far as I know, about exactly where it should go. But ultimately, right now, she's going to hang on to it. And ultimately, she's not expecting to hang on to it. That 40-some gram piece that was cut off, I actually continued to do cutting on that, talking with her. She wanted some of that piece, which is fine. We only need 20 grams. So we ended up keeping a little over 20 grams of the sample for future scientific work. We have to, in order to type the meteorite and to have it officially recognized. The institution has to retain 20 grams of material in this case, and for all future scientific requirements, in perpetuity. That's a requirement of the official process. So that's what we have. But she has other sample backs. So ultimately, one of the samples, a little tip end of it, she's making probably into a pendant of some kind. And then she has other samples that, she may keep or give to people. And the main mass, as it's called, she probably won't keep in the long run. And Robert asked, is she going to sell the pillow? Yeah, I think she is. She's not necessarily super attached to anything in that sense. It's like she also said she doesn't particularly need the money. So it's not like she's going to do a fire sale or anything. She's a cool customer, actually. She's thinking about what she wants to do.
And pretty lucky. Mahum's got a, am I pronouncing your name right? Has a question. Is there any particular time in a year when Earth gets such big meteorite pieces?
The answer is no, not really. I mean, we have meteor showers, like the one going on right now, but that doesn't translate into particular times for meteorite falls. The mechanism for delivering meteorites is kind of more sporadic than that, to use a meteor term. So there's no particular timing for it. There is some attention paid amongst meteorite classes. It's interesting, some meteorite classes, if you get enough statistics on their fall events, they tend to have a preference for falling in the morning or the evening hours, local time. So that says some vague thing about what the geometry of delivery is. So that's been known for maybe 40 years now, 40, 50 years. People have kind of had enough record of that in order to figure out that there is some distinction going on. But whether how meaningful that is, it's hard to say.
Any other questions?
Can I ask a question?
Yeah, go ahead.
I noticed the fracture lines are at 90 degrees. Is that just common in HLs, or is it common in all meteorites? And I want to know if the flow, was there any orientation to the flow?
The fusion crust didn't have any flow lines on it, so it wasn't an oriented stone.
Okay.
At least as far as I could tell looking at it. But what it did have is it had rollover rims on that that square surface that looked more brown, that you could kind of see through the fusion crust. Mm-hmm. So that surface, it kind of had a flow in that the fusion crust, when it was liquid, was was coming along and starting to lap over onto that big square surface that, you know, we notionally would call the bottom of the meteorite. That's how, if you just sit it on a desk, that's how it naturally wants to sit, is on that big square base. And so on the, you know, the quote unquote bottom of the stone seems to be a fusion crusted surface that was only very lightly melted and had stuff rolling out onto it. So yeah, it does have that sense of orientation perhaps. And as far as the blockiness goes, yeah, it's kind of characteristic for ordinary chondrites, and for some classes of achondrites, you get this kind of really brick-like appearance. And it probably has something to do with how the rock fails when it's mechanically coming through the atmosphere and getting essentially crushed by the atmosphere. That's what's happening to it. You know, it's going to fail along whatever fracture surfaces it has in it to start with, and so for those, they seem to be kind of at square, you know, right angles, and that's across the board. That seems to be kind of common. You get these typically kind of brick shapes or anvil shapes for ordinary chondrite meteorites.
Any other? Nikolai's asking, how much do these go for if someone decides to sell
Whatever you can get.
them?
Especially for something like this. I mean, there's no peer. There's no, this is a unique one-off. The only one that ever came through somebody's roof and landed on a bed right next to somebody while they were sleeping. I mean, that's it. There's only one. So what is that worth? I don't know. You know, you could start with the value of the meteorite itself as an ordinary chondrite has, you know, you could look up a range of values, so much per gram. Fresh meteorite fall, it goes up a bit. It's interesting scientifically, not that that matters a lot, but it has a known orbit, so that's cool. So it has, you know, kind of nerd value that way. And it's a Canadian meteorite, which tends to up their value because Canadian meteorites on the international stage are kind of hard to get. It's hard to export Canadian meteorites. It can be done, but they're harder to get out of the country. So that kind of ups their value. But then this one, because it's so unique and has all of these, you know, attributes that show that it's a hammerstone, that makes it much more valuable. So the peers would be other meteorite falls that were hammerstones. And I don't know what the valuations would be, but just huge. I mean, golden is a good name for it, and probably more than worth its weight in gold by far. I guess, yeah. It's just, you know, not really calculable. And really, that kind of thing, there is in the end a very thin market, very rarefied market for stones like that. It's not something that she would just sort of, you know, be able to put on eBay and sell. You know, that's gonna go through a collection house or through probably a high-end meteorite dealer and go to a museum or something like that is most likely where it's gonna go if she sells it,
And
or donates it. And donations, it will have that valuation too. That has to be assessed.
And Robert has a question. When it first happened, there was chatter on the in the talk group about what the temperature was likely to be when it got to the pillow, and so Robert's asking that, what was the temperature when it hit the pillow?
Stone cold.
Yeah.
Yeah, you know, well, it did whatever work it did coming through the roof would have maybe done something, I don't know. But, you know, as a stone just falling and then arriving on the ground, it has time for that fusion crust, whatever temperature that was at when it was still liquid. You know, it was molten rock, so it was, you know, 1,000, 1,200 degrees or something like that, but it's only millimeter thick and it's falling through the air. Once the fireball part ends and all the heat is over with, it's just then cooling and falling through the air. And so that fusion crust kind of freezes right away. And the rock itself, it never did heat coming through the atmosphere. It was basically at whatever temperature it was when it was in orbit around the sun, minding its own business, and the Earth got in the way. So it's not absolute zero. It's actually whatever the mean annual temperature is for the rock in orbit around the sun is basically not far different from the Earth's mean annual temperature, because it's on an orbit that was similar to the Earth. So it's going to be, you know, close to freezing probably. And when it hit the ground, it was probably around that temperature. Yeah. How big was it when it first entered? I don't know. I think I haven't talked with Peter and Alan about this yet. There will be some kind of estimate that can be done from the light produced by the fireball. You basically, if you make some usually pretty safe assumptions about what the material is, and we know what this material is, it's a chondritic rock, and you make some assumptions about, you know, what it takes and from the physics of the event, you know, the velocity coming in, you can back out of that, okay, how big was did the object have to be in order to produce all of that flash and bang? And I think the estimate is somewhere around a ½ meter or more in diameter. But I don't actually know the answer to that. I haven't asked Peter directly, but for this kind of event, that seems about right. A ½ meter to a meter diameter object is probably about right. So, you know, something about the size of a desk, like a regular desk, but all rock. And it was just, you know, minding its own business, orbiting the sun as a sort of fairly large meteoroid, and then it hit the top of the atmosphere.
I went
Okay,
through
well-
Golden. I went through Golden, BC once.
Yeah.
It's a bit slower than that meteor.
Yeah.
We were whitewater rafting on the kicking horse.
Oh, cool. That's nice. Yeah.
Mhm.
Yeah, I've only been there a couple of times.
That's
Just
nice.
heading west out of Banff.
Yeah, nice place.
Yeah.
Can I
Yeah.
ask a question, Mike?
Yeah.
Why were there two booms associated with this event?
Best guess is the booms. There are a couple of different things that give us sound. One of them is the fireball event itself when it's in the atmosphere coming in. When it gets to the lower atmosphere, which is still above the flood, you know, at the height where airplanes are flying. Typically, their planes are flying around 10 kilometers altitude. And this was the terminal point was almost double that. But in that range, as it's breaking up, there are big flashes at the end, and that also produces sound. And so those booms propagate through the atmosphere as sound waves and end up reaching the ground, and people notice. So that's one source of the major booms, and people widespread in the area all around Golden heard two booms characteristically. And there were basically two main flashes at the end. So that probably represents two major burst events. And in the end, we ended up with two stones in the ground. So possibly that accords with the two burst events, maybe. The other way it produces sound, which comes back to Ruth's dog, is pieces when they're after all of the fireball event, they're just dropping to the ground. They go through the sound barrier as they're slowing down. As the atmosphere is kind of finally slowing them down through the sound barrier, they will produce sonic booms locally. And so you'll hear little whistling, cracking noises, popping noises people often talk about in an immediate fall area. That's what we think probably that's what Ruth's dog heard just before the stone crashed through the roof, probably a second or two beforehand. The sound arrived from it coming through the sound barrier somewhere overhead. And then the meteorite arrived coming at, you know, a little less than 300 some meters per second, right? In terminal velocity for that stone. So, yeah, so the dog picked it up and reacted, and then blam, it happened for her. But the two booms are probably from the fireball event, and they were widely heard.
Okay, thank you. Very interesting. Thank you.
Yeah, no, it's neat.
Yeah.
Phil, the orbit. You said it had a unique orbit, a little bit out from Mars, which is 1.5, and you said 1.6.
Yeah.
This is very rare compared to the other ones that we have orbits of.
Yeah, most meteorite orbits, when they're known, the aphelia are usually sitting out somewhere more in the asteroid belt. So we're, 1.8 through to 2 point something AU, 2.4, 2.5 AU in some cases. So this one's it's a little bit the aphelion is at the innermost part of the main belt. So the tricky part about that is is in order to get a meteorite delivered from the asteroid belt, you essentially have to roust it out of there with one of the resonances, typically with Jupiter, an orbital resonance with Jupiter. So there are these Kirkwood gaps in the asteroid belt where you get a mean motion resonance or a different kind of resonance that basically the orbital period is a whole number fraction of the orbital period, typically of Jupiter, and sometimes Saturn. And what that gives us is a delivery mechanism for moving material because they get jerked around by Jupiter. It puts them on a less circular, more pronounced ellipse and drops the perihelion so that they start crossing Mars and Earth orbit. But there's no resonance available at 1.6 AU. So there's no immediate delivery mechanism for this meteorite. It had to start out originally somewhere else in the asteroid belt, farther out, near one of these resonance points in order to initially get liberated effectively from the main belt asteroids. And then the orbit had to evolve some more. So that's what makes it interesting, because we're now able to dig into that history if we get information from the rock itself with noble gas analysis and so on. There's a way of getting at that history to try to figure out what makes this L-chondrite different from the handful of other ones which have orbits which kind of tie them in with main belt asteroids. There is one proposal out there that a type of object named after the asteroid Gefion is proposed to be the source asteroid for the L-chondrites. And so so far the L-chondrite orbits that are known, there's only like 3 or 4 known, seem to agree with that, but this one wouldn't. So how does this one relate to the other L-chondrite orbits, and how do we get from there to here is the question. So it's going to be interesting for that.
It's going to be a good paper.
Yeah. Oh yeah, probably 2
or more. Thanks
yeah,
very
but
much.
the initial ones on the fall event in the stone, and some of the initial things that we can say about it and establish it's a meteorite, and that involves everybody that's in this so far. But the next information to come would be that cosmic ray exposure information and the noble gas analysis and so on would give us more of the meteorite's history as an object in the solar system, and how long did it take to get to the Earth. That's what the cosmic ray exposure age is when did it become a meter-sized object? Was it like 10 million years ago, 25 million years ago? And what kind of exposure did it have? It's over my head how to do that, but it's something that people do with meteorite falls, especially when they're well documented like this one. It's worthwhile.
This one will, I guess that stuff is still done down in the States rather than not in Canada.
Yeah, actually, yeah, a little bit in the States, and not so much anymore. It's this will be going on little pieces, little like 50 milligram chips are going to go off to Zurich and to the UK and places in Europe. But I mean, you could do it in Japan too, I suppose.
Okay, well, I think we should thank Phil.
Yeah, thanks a lot.
Thank you for putting together this talk. You're one of the busiest people I think any of us know, so we really appreciate you doing this for us. It only happened a couple months ago, so
yeah,
it's an amazing story, and I really appreciate it.
Yeah, you're very welcome. This, as I mentioned off the top, this is actually the first time I pulled this talk together, so I did that today. And it was fun, fun to actually pull all the information together, because I've sort of been thinking about things, but I hadn't, collected it as a story yet. So and it's nice. It's nice to do that. So thanks for the opportunity.
Well, thank you very much, Phil. So we'll go on now and look at some member observations. My connection's been a little bit unstable. I dropped out for a minute or so in the question period. So if I disappear, Randy has the slides and can take over. But I'll share my screen now and invite, what I've done as I did last time was I've got lots of pictures, but for people who submitted a couple things, I've asked them to pick one to talk about. So we'll look at them as we're going along. So can you see my screen now? Yeah. I've got these in roughly chronological order. There was a lunar eclipse just after our last meeting, but I don't think anyone here saw it, but Richard Lambert got a picture of the moon, I guess, before the eclipse, and Randy did. And I guess is Richard here? I don't think Richard is here,
No.
right?
No,
So,
no, he's not.
and Chris Stevenson got a picture, and here's some of the details. This is with his new Canon SL3. And of course, if it's going to be a lunar eclipse, it's a full moon. So that's a nice picture there. And Randy got some pictures the next night. So we've got around the full moon, we're getting some full moon pictures. And I think the next one is also Randy. So these are both on the night after the lunar eclipse. And then Randy, do you want to say a little bit about this picture? This was the next night. And people can maybe think about where Randy had to be to get a picture like this.
Okay, as you know, sometimes we get, like this weekend coming, 3 pretty much full moons. I think the full moon is actually just a couple of hours before it rises this time, 100%, but the day before and after it's 99%. So in terms of photographs, it's still pretty good. That red object down in the bottom there, should I say what it is?
I know what it is.
It's Cabot Tower.
Have a tower.
There you go.
There you are.
I've been after a particular shot, and I'm using some of this to gauge accuracy of some of these planetarium programs and stuff, and how long it takes for the moon to rise certain areas. And of course, as almost always happens for us, it's pretty cloudy down at the bottom. And this particular one was a really nice view with all the banding. Unfortunately, by the time the moon came up through the bands, I had lost the shot that I wanted. So this is actually taken from the cemetery off of Black Marsh Road, Mount Pleasant, I think. It's the, so
So long way away.
and that particular one, I think, is about 800 millimeters. So if you want the big moon, you go farther back. But I take maybe 50 or 60 of these every full moon, and I don't often share them. So
Okay, so thank you.
Okay.
Nice shot through the clouds. And so Robert, you want to say a little bit about this one, your bubble nebula?
Can you hear me?
Yep.
Oh, yeah, okay. Yeah, this was taken right around Roach's Line outside of the city with a 5-inch refractor and ZWO dedicated astronomy camera, the 2600, I think, is the number one. And it's a I took 6 5-minute images. So the scope was, or the mount was guided to, in order to track sufficiently correct to be able to capture the object. And it's called a bubble nebula. It's up in Cassiopeia. And as you can see, indeed, the central cavity does indeed look like a bubble. And that's caused by stellar winds from a star somewhere central to that, which is blowing the gas from the nebula away from itself, and hence you get the effect of the bubble. So that's about all I think I can say about that.
And there was a nova in that neighborhood earlier in the year. I don't know if it's still there, or if it'd be in that field or not. Chris might know.
Yeah, I don't think it would be in that field, but you're right. There was one very close.
Almost in that field. I think if you go straight down from the bubble nebula and left of the cluster to the lower right is M52.
Oh, right.
Congrats on the image, Robert. That's a nice image. But apparently that nova is still relatively bright. You know, most of a year after it was discovered in the spring. So it's still there. I think it's just outside the frame on the bottom though.
Yeah.
Yeah. Just to the right.
Okay, and so Jim sent in a couple images. This one is M81, M82, and the data for that is on the right here. Lovely image, and you can see in the in M82. So this is M81 Bode's Nebula and M82, and you can see something slightly different in the middle, which I guess are the beginnings of a jet, which you can't really see the rest of the jet. But the one that Jim's going to talk about is this one, I think, right, Jim?
Jim is not on.
Yeah, that's right. Yeah. Yeah, we haven't had very much in the way of clear nights this past month. And so, yeah, it was on Friday night of last week that we had, you know, a few hours of clear sky just shortly after sundown. And so this was, I guess, November 20, was it? No, that's not November 21st. This would be just last Friday. So, yeah, so I was just out because we had such poor skies. I just took the opportunity to set up the gear in the backyard because I wanted to refine the focus on my guide scope and then do some work with a new electronic focusing setup that I had attached to my imaging rig. Now, those who have been following me for the last couple of years know that I'm trying to do astrophotography with a Canon telephoto lens. That's a fully manual lens that dates back to the 1980s. So it's a bit of an antique lens, but it is particularly good lens. It's basically equivalent to a triplet APO telescope, and with an aperture of 110 millimeters. And what I like about it is it's relatively light, so I can use it on a relatively small mount. But I've been trying to refine my technical ability to take astrophotos, and this is just the double cluster in Cassiopeia, which has got lots of stars. And since I was looking to refine my star focusing algorithms, I thought this was a pretty good target for that type of testing. Now, this particular photo is rather flattering to me because the stars are relatively small, so you can't really see the fact that they're actually shaped like little triangles. So I've been trying to figure out why I'm not getting nice round stars. So that's basically the experimentalist in me. I've been working for years now trying to get round stars. So this particular example was a failure, but when I Google triangular stars, I find that it's due to something called pinched optics. So I started looking at my rig and trying to figure out why the optics would be pinched, and sure enough, I had various problems with the way I was holding the lens with telescope rings and so on and so forth. So because we get so much cloudy nights, I get lots of opportunity to refine my rig, and I'm looking forward to the next sucker hole to come by, so I can continue to do some more refinement to my to my images and my astrophotography and try to get my round stars. So this was about an hour and a half of exposures time. So the more exposure you get, the more of the faint stars you get. So yeah, so next time I'll continue on with trying to get more stars and trying to make them round next time. So tomorrow night, maybe.
Okay, well, thanks. One of my favorite objects. I love the double cluster. So Bernard won there was a comet around the last couple of weeks, and Bernard got, I think, the nicest picture that anyone in this group got. So you want to say a few words about this one? And then I have a video a very short video that Bernard sent, which hopefully I'll be able to run after this, but I'll let Bernard say something about this first, and then I'll try and ask Randy to stand by in case the video is the last thing I do on my computer before it dies. So go ahead, Bernard.
Yes, hello guys. This image was taken on December the 5th on a Sunday morning there. Went to the cabin and got up real early. Was lucky that it was cloudy when I went to bed, but when I got up, the sky was starting to clear, so I got everything ready. Used the ASI 294 Pro camera on my Mead LX200. Anyway, when I got it set up, I used this Sky Safari Pro program to slew a telescope and to find things in the sky. So I lined it up on Arcturus, I think was fairly close to this comet this morning. And I focused on that one, and then I just moved the telescope not too far and took a few pictures and with fairly high gain, and the comet just popped into view. And I was really surprised, to tell you the truth, that it was going to be so large on the screen. But so I spent the rest of the morning until daylight taking more pictures and took a lot of images, I guess. And this one here is just one of them. I've been trying to learn PixInsight, and I tried to stack a bunch of them, but where the comet was moving so fast, it didn't work. I used to always get the stars were okay, but the comet would be just a blur, the way I was doing it anyway. But anyway, yeah, so I processed that one the best I could, just as one image, and that was the result right there. So after then, I went in PixInsight and I took a bunch of other images and put them through a process called blink in PixInsight, where they sort of lined up the stars, and you could see the comet just moving through. And I think they're like, when you get to it there, Mike, it's a 30-second.
Yep. So I'll give that a try now.
Okay.
So see what happens here.
There you go.
Can you see that?
Oh, nice.
Yep. Yep.
Okay, so I'll run it a couple times.
Wow.
Yeah.
Very nice.
The video quality in that program was not real good. Like the images were quite a bit better than that, but when you put it through, I guess the video quality is not real good. But you can see, and Gary pointed it out, that the tail of the comet came right down between two galaxies, in the distant galaxies there.
Yeah.
Yeah, it's beautiful.
And there. That's great. So yeah, I think on the next slide I've got the amount of time, but these are 30 seconds per picture, and there's a couple 1-minute jumps. So I figured it was like, that's about 12 minutes of motion. Does that sound right?
Yeah, that's about right. Yeah, yeah. I think there's a couple images that I took out of there because there was a satellite came down across at the time, and one was a bit blurry, I think.
Well, that's really neat. Okay,
So it looks a little elongated along the path of motion. Is that just its movement during exposure time? If you look at the kind of the what is it, the coma area, that the brightest part,
Yeah,
it's not quite a round ball. It's a little bit elongated along the path of the comet.
Yeah.
yeah, and sort of moving across there, I guess, and it's not when you look at it, it's not moving. The tail is not pointing away from directly, I guess, from the direction of which it's moving. So I guess the tail is pointing directly away from the sun. I guess that's the way that works.
No, that's right. But
Sort of teardrop shaped.
yeah,
Yeah.
I think that I think you're right, Phil, because I saw the same thing in my picture. It's moving so fast that if you do sort of a 15 to 30 second exposure, you could actually see a little bit of the
yeah, it's spearing during the exposure. That's absolutely remarkable.
Yeah, it's
Yeah.
one fast-moving comet,
Yeah,
and it's smeared by about the amount it moves per frame. So that's
yeah, that's cool.
Yeah, I guess that's what it is, 30 seconds, and it just that's how far it moves while I was exposing it, I guess.
Yeah. Oh,
Nice
very
job
nice.
getting those. Oh, sorry, I was just gonna say, really nice job getting those two background galaxies. That's.
Oh yeah.
Yeah, I didn't know that was those background galaxies were going to be there until after I looked at it. So that's just it just worked out that way for sure. The one on the left, Gary pointed out the galaxies there. The one on the left is IC 4382, and the one on the right is NGC 5008. I looked it up on
Very nice.
Starry Night.
Yeah.
Okay, I'm going to try and go back to the slides now. And there was my slide about the video, so that worked. So Chris also got a picture of the comet, a little bit fortuitous. And there it is right at the bottom. And I guess Chris did many pictures without the comet in and then caught this one with it in.
Yeah. Cold morning. You get up at 5 and you're tired, and you have the camera on the tracker. This is just an SLR with a 75 to 300 millimeter light telephoto lens on it. And there's an urban park about 200 meters away. Walk to the park, set up rough polar alignment for 30-second exposures, 75 millimeter focal length. So this is a fairly large-ish chunk of sky, but clearly not large enough because and dodging clouds, lots of clouds, and until it sort of magically cleared around 6 o'clock, and then at 6:30 it's too bright. So I was trying to find the comet. It was too faint to see. So you're pointing blind based on a little rinky finder chart you bring out with you, and you do your best, and you carpet bomb the area with photos, and then, oh, it's a clear hole. Then you shoot 20 photos in a row, and you cross your fingers and hope you got the comet. I did not get the comet in those 20 photos. Then just before I packed it all down, and the sky was starting to blue, I said, oh, fine. I'll just dodge the camera down a little bit, a couple of degrees, and try again. And the comet just snuck in on the edge of the frame. Do you have a crop in on that, Mike, or maybe not?
Do I have a what?
A zoom in on it, a crop.
No, sorry.
That's okay. So yay, record the comet. At least I can say I got this one as well. Bernard, lovely job. Thank you. Yeah,
Okay.
anyway, sorry.
Oh, Chris, you got the zoom out view.
Yeah.
Oh, sorry,
And-
yes, that's right, barely.
So Gary did a sketch, and so there's it's a base. I guess that's a pencil drawing, and then you convert it to a negative. Is that right, Gary?
Yes.
And very nice to see someone using the other kind of technology.
I'm
And-
old school.
What's
Love
that?
it.
I said I'm
More
old
sketch-
school.
Love it. Need more sketches. That's great.
Yep. And Randy and I went out Monday morning, and it was pretty cold. And I was using an AZ GTI mount, which I could control with my phone, so I could download. Randy told me how to download the Comet database. And I did get a picture on the Monday morning, but I didn't really have it in focus because I was just using my camera. I'm used to focusing the telescope, and I didn't even think about if I'm just using the kit lens on the camera, I need to focus it. And I even said I was going to swing to Arcturus and focus it, and I did, but I swung to Arcturus in the line, but did not focus it. So I went back on Friday morning, and it was even worse. It was cold and icy, and it was cloudy, but there were gaps in the clouds. And it was windy, if you remember Friday morning. So I set up next to the tower. So this on Signal Hill, set up next to the tower, and just took a lot of pictures, sort of from about 20 after 5 to 20 to 6. And there was nobody up there until just before I left. The Monday morning when Randy and I were up, there were people coming up quite a bit, but Friday wasn't as nice. And I posted one of the pictures, and then Robert said, too bad you don't have lots of pictures, you could stack them. But I realized, I do have lots of pictures, and they all have clouds somewhere in the picture, but they don't all have clouds in the same place in the picture. So I did stack them. So there's the comet, 21 frames. I didn't have to worry about doing the comet stacking because it's such wide field that the comet doesn't move very much. I use Deep Sky Stacker, and the comet didn't really register in Deep Sky Stacker, and you can sort of pick out the comet manually, but it was so small that I probably would have made it worse by trying to stack on the comet rather than letting Deep Sky Stacker do the use the stars. But you can see there that the coma is a little elongated too. So that was my shot at the comet. And
Very nice, Mike.
thanks. And another thing that happened last week was this lineup of the moon and the planets. And so Gary took this picture, and there's Venus, there's Saturn, there's Jupiter, there's the moon, and Gary's given us a map on a slightly different day. So Gary, you want to say a bit about that one?
Yeah, I just delivered some pictures to some groceries to my brother, and I came out and the sky was clear and I saw it lined up. So I took out my Samsung phone and put it up against the car and took a picture. But my phone also has a Pro section. Not all the Samsung phones do. So I put it in Night Pro, and what's interesting is that Night Pro gives me an ISO of 1600, and it stacks them. So that's a stack of 1/8. So that's a 3.75 second picture. So next time I got to remember to put it on a tripod.
Yeah, you got to hold it pretty steady that's pretty impressive for a phone.
And if you had zoomed in on the between the moon and Jupiter, there also another one showed up, and I thought it was the asteroid because it was in the same position. But when I went to Stellarium, it was the star stack, which was 3.5, which I knew wasn't going to come up. But I thought it was pretty good. And on the picture, it shows the ones lined up, but Pluto is actually right next to Venus that night.
Yeah, it didn't show up for some reason.
Yeah. I don't know why.
You
Must
need
be-
you need a better phone, Rick.
No, it must be a twilight.
Well, I thought,
Okay.
you know, it was just so pretty. to
Great,
see.
thank you very much. Yeah,
Yeah.
a lot of people were looking at that and commenting on that alignment that night. I don't think Jim is on with us.
No, he's not.
No. So this is his observatory. We've sort of been following the story on RSCNL Talk as he's been building this. Everything about it's pretty impressive. And I guess this was his first image using the setup in his observatory. So that's kind of momentous in that regard. And so it's an ED80. There's the camera is a ZWO, and the mount, of course, is very impressive on a pier. And he just used M42, the Orion Nebula. And I think we're going to see some amazing things from that pretty soon. And Bernard also sent a couple pictures from his observatory in the summer. The Pleiades, again, using his 12-inch, and you know, lovely picture, and the Horsehead Nebula and the Flame Nebula. I guess that's the Flame Nebula, right? And
Yes,
that
actually,
must be Elm Attack right there.
Yeah. Actually, Mike, the scope I used was a newer scope that I have bought recently, as a Sharpstar 61 ED PH with a reducer.
Oh, so I messed up. It wasn't
Yeah.
your 12-inch.
Well, I was mounted on a 12-inch. I mounted on top of the 12-inch.
On top of the 12-inch. Okay, so what?
I was using that for guiding, but I took the picture with the other, you know, wide angle the scope.
Oh, of course, yeah. I guess I should have thought about that when I realized how wide the image was. Okay, thank
Yes.
you very much. Thanks for the correction. And Gary, I'm gonna again try and run a video here. Gary just posted a couple days ago something from his Meteor camera. Fingers crossed. Can you see that?
Yep.
Yeah,
Oh, yeah.
that's the Geminids.
There we go.
Yeah. And a few clouds. I'll run that
A
again.
lot of clouds.
I think
Pretty
Over
impressive.
the past 3 nights, I've had 88 caught by this camera for Genemides alone, and the peak was 98, I think, and last night was 55, and we've had nothing but bad weather like this.
Yeah.
So if it had been clear, it would have been some shooting star show.
Yeah,
Dave Newbury's Skycam caught a few as well, but his that's on our website. The video is quite fast though, so you need to really slow it down to catch them.
Hey, so thank you everybody that sent in pictures, and I'd encourage anyone else that wants to send in pictures, or even just a verbal description of your observing, or a sketch to do so, and we'll fit them in. And now I'm going to turn it over to Nikolai, who's going to run us through the sky this month. Are you there, Nikolai?
Yes, I am. How are we on time?
It's 9:18. Take 5 or 10 minutes.
Okay. Well, I can focus on the comment because that's the most interesting part. Let me share my screen. Okay, can you see this?
Yep.
Yes.
All right. So this is the sky this month. Well, for the next month, really. So this presentation is uploaded on our website. We can reference it there. Here are the sun-related phenomena for today. So sunrise is 7:42, sunset is 4:09. It's almost as long as you get for a night throughout the year. So make sure you use that. These are the planet rise and set times for today. They won't change a whole lot over the next, couple of days. So that's valid for next, I'd say, week or two. This is a current picture of the sun. This is a typo, by the way. This should say today's date. You'll see, decent bit of activity, which is a continuation of, the uptick in solar activity that we've been seeing over the past couple of months. So that's at least, 3 groups of sunspots that are rotating into view. And so definitely, good stuff going on here. Because anybody actually looked at the sun and seen this the last few days? Should be a good display, over the next week or so. Planets. In the evening, we have Venus, Jupiter, Saturn, Uranus, and Neptune. They're all, I would say they're all early evenings. So a few hours after sunset is when your best chance is. Pretty well cluttered evening sky. In the morning, we have Mercury. Oh, wait a second. No, Mercury is an evening planet, so that's another typo. Sorry about that. I'll fix that. So Mercury is actually, yes, it's definitely an evening planet because it does get fairly close to Venus, especially between December 28th and 31st. So that would be a great opportunity for you to spot Mercury. Yeah, because
I think Mercury just moved out of the conjunction with the sun. Looking at the Soho thing.
So it was
just came off screen.
Yeah. Mars is definitely a morning planet. It rises 1.5 hours before the sun. So still pretty small and faint to really observe in any meaningful way. But it's working slowly towards its December of next year opposition. So that's something to look forward to. Comets, here is of course the list with Leonard being at the top. And this is your extremely difficult December observing challenge, is to see Comet Leonard. If you've already seen it, it counts. Don't worry, you're not disqualified. But right now it's extremely difficult to spot because what's happened is it's past this closest point to the sun. And so it has transitioned from a morning to an evening object, and it's extremely low. However, there was a report that the comet brightened unexpectedly today, which is good news because you do need that magnitude to go down, I guess, to become more negative. So because it's in the evening, bright evening sky right after sunset. So on December 17th and 18th, it makes an exceptionally close pass to Venus. In fact, some people are wondering whether it's going to cause a meteor shower on Venus, something that may be difficult to confirm, but you can use Venus as a guide to find it. And here is your finder chart. It's probably a bit small. Let me see if I can increase it a little bit. So this is your finder chart that you can use. I actually have it loaded up on Stellarium. I think that will be more useful for people. So this is today, about an hour after sunset. So you can see it actually forms almost a perfect line with Jupiter, Saturn, and Venus. And you can see it's lower than Venus. so that's makes it really hard. But I'm gonna progress here and go to tomorrow, and then the 17th and the 18th. So these are the 2 dates where it's just below Venus, very close. You know, that should make it easy to identify the area where it is. Doesn't necessarily mean it's going to be easy to see, because its magnitude, as you can see here, 4, and that's a prediction that might be off depending on how things go. But it's a very bright sky just an hour and a half after
What's
sunset.
the forecast for the 17th and the 18th?
So the forecast looks best for Thursday and Sunday. So today is the 15th. So the 17th and the 18th, actually the forecast looks bad, but it looks good on the 16th and the 19th. So still not bad, but I'd say those will be the only 2 days where you have a chance to spot it. After that, it gets difficult because this happens very quickly, you know, just over the next week. This is what it does. So as you can see, it's directly to the southwest. So if you're in St. John's, if you're on Signal Hill, right here, southwest is looking directly over the harbor. So however, you'll be dealing with, you know, all sorts of lights and whatnot, which I don't know if it makes a difference when the sky is bright anyway. But if you want a very clear view of the horizon, you'd have to go somewhere where you have water to the southwest. So anywhere along here would be fairly close. But yeah, it's definitely a challenge. And
Bali to Hollywood, you're saying?
no, I would say CBS to Bali, something like that. Somewhere where you're not blocked by Bell Island. Something like that. Anyway, I mean, ideally you'd go down here, but also the weather down here is not as good usually. So yeah, here's probably the hardest challenge so far for you. So that's the comment. Here's a list of some asteroids. Supernovae, brightest one is 10.9. Nothing really significant. Meteor showers, we had the Geminids, still ongoing, but the peak was 2 nights ago. I observed for about half an hour and saw it was close to 20. Or was it for an hour? Anyway, it was a very, very decent rate considering I was looking out through my downtown St. John's backyard with clouds passing nonetheless. So I thought it was a pretty good show just for that. Here's a list of some deep sky objects that are very well placed for the months of December and January. International Space Station passes over the next month. Observing sessions which are not active right now. Hopefully we'll look into resurrecting them soon. But yeah, that's all I have. Are there any questions?
Just remind everybody that the this PDF is available on the webpage. Yep. So if you didn't memorize everything that Nikolai said, you can go and review it, especially all the binocular and telescope objects. Okay, thank you very much, Nikolai.
No problem.
Anybody got any questions for Nikolai? So I'll just finish up the formal part by there we are. So we actually have next month's speaker with us tonight to sort of see what we're up to. So Mahum Gaffer is going to talk. She's a PhD candidate at Grenfell, She gave a talk in October about dark matter, and she's going to sort of give us some more information, or not many of us were at that talk. So we're going to hear about dark matter from Mahum at our next meeting, which I believe is January 19th. And so thank you for joining us tonight. Mahum, I guess you're still there?
Yes, thank you
Yeah.
so much.
Good. And thank you for agreeing to give us the talk next month. So that's something to look forward to. At some point in the new year, we'll probably send out a survey. And so when you get that, please complete it. I've been a few people have sent me observations. I've been mostly mining the RASC NL talks, but some people aren't on there. So if you want to send me reports or photos, you can send it to, well, I've got info. We've also got a photo email, which I should have had there.
Either one is good, Mike. They end up in the same place.
Okay. And it's mining the pictures out of the chat group is okay right now because it's cloudy most of the time and it's not too overwhelming. But if it ever gets clear for a whole month, that's going to become a huge job. So I certainly appreciate when people actually send me a photo and tell me this is the one they want to look at. So, but we'll deal with it, however. And again, I encourage you, if you want to give a talk, you don't need to be an expert about the topic. You can be someone you can basically give us our most recent talk, and the next few are from experts, but we also get talks where somebody has picked out a topic that they think is interested in, and they basically give us a report about what they've learned on that topic, and that can be very interesting too. So I'd encourage that. So that ends the sort of formal part of the meeting, but I'd invite everybody to hang around for a little bit, and this is where we would be eating cookies and having coffee and
rum cake.
and rum cake and stuff like
Yeah.
that.
Missed
If
that
it was
rum
a
cake.
normal time,
I
Myself
should remind
you can
Mike?
look festive if you want.
and
Mike, I should remind people that Web launches next week.
no,
It's been delayed by a
yeah,
couple more days, I think.
Christmas Eve
Oh,
now.
okay.
Yeah, it's the 24th now.
Wow.
As if we'll
So
be
keep
watching.
Fingers crossed for that. Everybody
They've got
think good thoughts.
communications problems, don't they?
Yeah, oh, yeah, that's right. Between the payload and the rocket carrying it. I think it was.
The solar
Sounds good.
satellite go to the
Parker
the
probe,
sun?
yeah. Yep,
today?
yep. The
Right,
graphics
what
on
was that one, Gary?
the Parker probe hit the sun,
Oh, right. Yeah, I saw something about that.
but the graphics they're using on the news sites has the probe going straight at the sun, right? So
Yeah, that wouldn't be recommended.
NTV had some actual footage of it going through, which was kind of cool, actually, and picking up some of the whatever
myself and Mike discovered an anomaly using our SynScan app, trying to locate the comet in the app. And I said, I had to keep trying to update this app to the comet list, but by default it's set that only shows you comets that are above the horizon, so you can't do any pre-lookups to see where what the data is. So it was a funny one. All the other ones do show it, right?
Yeah, that actually, that I found that really worked well, at least for wide field for my comet shots. I aligned on Arcturus, and then the comet wasn't far away, and the AZ GTI is the little light Skywatcher mount. It just went centered very nicely. So
My horns don't show because it's black above. So they disappear when maybe I can do.
They're magic horns.
Yeah. Even my my little other cap. I got one on each side now, right? So
Phil, thanks for your talk.
yes, Phil.
Yes, that was great, Phil.
You're welcome.
So I wonder how much you'll get for that meteor.
Oh,
Yeah, I've no idea. We did talk back and forth on that, and I said, first, I am not the person to do evaluations, so no, I can't tell you any particular number. Just broadly speaking, you know, these things are usually like six-figure kind of deals by the time you're done. But yeah.
I'd be curious to know what she gets for the pillowcase.
Yeah, well, you know, I told her there's lots of value added in this, actually, you know, just the roofing materials and the pillowcases and bits and pieces from the outside, and really anything that's conceivably part of the event is something that has value to somebody.
This one is less than a gram. This guy Murray Paulson.
Yep.
He sells them at conventions and stuff. So that's less than a gram. I think it was $25, right?
Yeah, that one is buzzard coulis, or what is it?
No, this is a lunar.
Oh, okay. Yeah, that's why it's $25. Okay.
Yeah. I had the chance to get a Martian one, but he was all sold out at the time. So
yeah.
he goes over to Algeria, I think, as well, and mines them out of the sand, I think.
Okay. Yeah.
These glasses.
Yeah, that's a fun thing. One of the there are people who have, you know, the time and the finances to go and do searching places, which is kind of neat. There's a fellow who got in contact with us, same Impact Earth website that Ruth used earlier this year. A fellow living in the Eastern Townships in Quebec got in contact with us and said, well, you know, I have a hobby. I go look for meteorites. Oh, you do? Okay. And he's for real. He goes off to the Atacama in Chile and goes and just searches there, and the Chilean laws are you can do that. You can go look for meteorites, and if you find meteorites, you can leave as long as you inform people of what you're doing, you can leave the country with them. And yeah, so he had 4 ordinary chondrites that he picked up. He had GPS locations for everything, described them very well. So we're just about to submit those to Meteoritical Bulletins, 4 new meteorites. So it's just, wow. And he's 70 years old. He's just a retired guy. He was an engineer. He just decided he wanted to do this, and gives him a chance to travel the world and do stuff. And yeah, it's pretty cool.
Good for him.
Yeah, it's other people chase eclipses, right? I mean, everybody's got something that gives them a turn.
Yeah.
Yeah, they didn't have much luck in the Antarctic this time.
No.
3 out of 4 cruise ships got canceled, I think. So.
Just imagine all the meteorites that are in Newfoundland, but obviously still uncollected because of our terrain.
Well camouflaged, I would think.
With 99.9% rock on the ground, it's going to be tough to find them, right?
That's right.
Yeah, it'd be very tough to find them.
Well, Gary has been talking about this for a long time. You know, the best time to do this is in the winter. If there's ever a fall event where you get a fireball, you put something down, go look at all the ponds that are frozen.
So you know, Gary is taken to wearing a bullseye to bed now, right?
I thought Gary found one in his driveway one time.
Hey, he sleeps with a pillow over his head, right?
Yeah,
just in case. Right?
Pillowcase. Yeah.
Bill, the lady who got the meteorite, she was incredibly lucky. She had a pretty close call. Did that have any sort of impact on her? And a lot of people would you know, that would be, you said a life-changing event, but that's a life-changing in a couple ways. That's
Absolutely.
Life ending event.
Yeah. No, I don't know the details of Shan. She's not, effusive about that, but she's, she basically in conversation kind of shrugs it off as yeah, that, she's pretty deadpan about it. It's like, yeah, that was a pretty major thing to happen. But the fact that it took her about 3 days to want to start telling people beyond her family the story, she took some time to sort of process this. That was, and it's like having a near car accident or something like that. Like you have something, that's the only thing I can equate to it is that,
yeah, that's what I was thinking about.
you have an incident happen where you're driving a car and you spin and go off the road and roll over and you might have been killed. And, it kind of, I would say, takes you a little while to sort of go, well, I'm still here. Okay, what am I doing with my life? I can imagine that a lot of this stuff has gone through and is going through her mind, and she's in no hurry to make some big decisions about anything, which is great. She's very level-headed. It turns out she's the former head of the Chamber of Commerce in Golden.
Okay.
And she has, I don't know if she still is, I don't know that much about her history, but she did run the local microbrewery in town.
That's where she got that attitude, right?
So yeah, no, so she's cool customer. Like nothing phases her really. But I mean, this was a pretty good shot by nature to phase you,
Yeah.
Anybody having that happen would just like, wow, that's an amazing thing. But no, she's really level-headed.
That's great for her. There may be more than one, but I only know of one incident where a human being has been hit with a meteorite.
Mm-hmm.
And actually,
There was
our
one.
daughter asked, and I forget her name. It was like 40s or early 50s, late 40s. Do you remember the name?
I had it at the tip of my tongue a while ago. I can't call it to mind right now, but it was in Alabama. And what was her name? Anyway, yeah, the stuff. It
and bruised it.
Yes, it came through the roof, bounced off the TV, and she was lying on the couch, and it hit her in the abdomen, and gave her a big bruise.
Wow.
But that was a case where the only recorded case where someone has been hit by a falling meteorite. So this is a near miss kind of case. There's another one in Kobe in Japan several years ago, but in this last decade, where a meteorite came through the roof and landed in a room. And I forget the details. I forget if somebody was in the room or not, but it was similar. It was a bedroom kind of thing. So this is, these things do happen. They're rare, but yeah, they can happen.
Miriam had a very good question, our daughter. And I didn't have an immediate answer per se. It's a simple question. If a meteor is falling towards the ground, of course, when it gets to the ground, it's a meteorite. And what if it hits you first? What's it called when it hits you?
It's called ouch.
Or a weapon,
Yeah. No, I think we count as ground in this case.
Oh.
I don't know. That's kind of splitting hairs, as it were. But
not everybody's grounded.
Yeah.
So Ruth's meteor landed on a bed. It never got to the ground.
It never got to the ground. That's right. It's still a meteor then, I guess. Yeah. I didn't think of that, and I didn't drop it either. So.
I guess if it struck you, it'd be meteorific.
Oh, jeepers, God.
Yeah, we're scraping now, aren't we?
Talk about father jokes.
Oh dear.
Nikolai, that picture that we were showing of the cloud at the night of the lunar eclipse, the only reason I took the picture, because I had already decided I wasn't going to see the eclipse, but the moon was very iridescent. The cloud was a strange color that doesn't show up in the picture at all. There's really pillow puffy clouds all around it as well. I think somebody else posted on Twitter about it as well, but
I can't remember. I don't think I
can show you.
okay.
This one.
There. Oh,
oh,
yeah,
there
there
you
you
are.
go.
Hey, well, that's
There we
neat.
go.
So that's looking almost straight up at my roof. And like I said, it doesn't really show the really electric blue and other colors around it.
See the colors right on the bottom, blue and top.
So this was the one next to it. There was a
Oh,
hole
yeah.
right up through. There was a hole, right? So yeah, that's as close as I got to the eclipse that night. What else? You've seen all these other ones, right?
Yeah, I think that happens with with mid-level clouds. I think I've seen it before. With
Can you imagine
I
that
wanna
that
say-
moon had been down there?
That's quite a telephoto shot to make the moon that much larger than the tower.
Mm-hmm.
But the moon must have risen to the left of the tower.
On that particular night, just notice how big that moon is compared.
Yeah, compared there to the tower. Yeah.
Yeah. And it's amazing, like this is solid cloud here, right? And once it gets up a little higher, you can start to see some of the features. Right, and then there's this band of cloud. So, but it's not.
Oh, wow.
Guess whose famous birthday was yesterday? He had a pet moose, if that helps you. And he cut his nose off in a sword fight.
Oh, Tycho Brahe.
There you go. So,
But he died from his bladder busting from drinking too much.
yep. So that's only like a minute or so later after it gets up out of the cloud layer. So, but you can you can tell it's not 100% though, right?
Yeah.
So.
I can never see the man in the moon. All I can see is the woman in the moon now.
And just a minute or so after that
Bias.
picture, along comes another cloud bank, right?
Yeah.
So
I see a big ant in the moon.
Yeah.
yeah. So anyhow, the moon
No
is
imagination, guys. No imagination.
the
I
moon
see
is
it's a
cool.
rabbit paid by Playboy.
This is another spot from that night before.
Wow.
They were picking different colors to light up the tower.
Yeah.
Blue that night. It was red the next night. I won't share all my secret locations. But
Is that like are they doing like the government house now, which has a different color every night,
yeah,
celebrating different?
Yeah, Confederation
different
building
things?
is lit up for. I think they're gone to the Christmas colors now for the season.
I know they for every event like breast cancer or you know, diabetes week.
Yeah. Yeah. So I went to again.
Wow, it's blue there.
Yep. And this is where the moon rose that night. So
Yeah.
So the software you're using to find out, because you're trying to get the moon behind Kappa Tower, right? Is it off a bit, or are you just not
well,
getting the right?
the issue is that you have to calculate your altitude versus the tower. So the tower is about what 300 meters high, and you got to know the angle that the moon is rising to calculate that distance, right? Instead of this one, because it'll come up. So if you want a particular view, you have to calculate how far over. Unless you're at sea level, it's great. You know, if you're getting sea level shots, it's no sweat. Sun's, 3 minutes after. Well, there's the other issue is there's like 15 different definitions of what moonrise is, right? Is it the very first peak of it, or is it when it's all up, or when it's half up? So
Yeah, you either see you're I was thinking maybe there's a building in the way where you want to set up or something, because you always seem to be to the right or to the left.
Well, like the problem is calculating where the moon's going to be to get up behind the tower. Is it 6 minutes? Is it 9 minutes? Right. So it makes all the difference of where it actually appears. Right.
So I'm hanging on by a thread here. I'm
you?
going to wish everyone a happy Christmas.
Happy.
And
Happy
Maybe-
nogging.
sorry,
Happy nogging, everybody.
happy
Nogging, yeah.
nogging. Yes,
Yeah.
indeed. Some of you I'll probably be talking with over the holidays, perhaps. The wonders of Zoom. Yeah, I may try and look at that comet again. One last. I
was
initially
like-
said that the comet wouldn't be visible in the evening sky. I'm not entirely sure I counted that low in the evening sky as visible, but well, Nikolai's got it out there.
Yeah.
Give it a shot.
Yeah. Well, we've been getting a lot of sucker holes, I must say. Forecast says cloudy or snow. And I
So
look out the
tomorrow-
window and there's Venus blazing away. And,
There you go.
I'll
Anyway,
be-
folks, happy nogging.
I said. more-
Okay, I
Yeah.
guess we should probably wrap it up pretty soon then.
okay.
Yeah.
Oh,
Thanks again, Phil. That was great, and I know how busy you are, so
Phil,
really appreciated that.
Great,
Oh, yeah. Yeah.
Phil,
That was a lot of fun.
It was a
you,
great time.
you have one of our mugs, Phil, don't you?
Yes, I do. Yeah.
What color?
It's
do you
actually,
have?
it's here in Hamilton. I keep it here.
Okay. Do you want another one?
Next time I visit,
Okay. So you get one. for each-
hopefully in the next few months, if
for each-
things
for
open up
each
enough,
set.
I'll come
No,
visit.
Not the way it's going.
I know, not right now, obviously, but yeah.
Yeah, everybody stay safe.
Yes, indeed.
Okay. Good night, folks.
Yeah.
Merry Christmas.
Merry Christmas, all.
Thank you.
Bye.
Merry Christmas.
Yeah.
Merry Christmas.
Happy solstice. Well,
Good to see you.
Bye-bye.
Happy
See you in the new year.
Newton. Happy Newton birthday coming up.